All right, getting ready for STAAR, we have TEK A-3C, which is identifying key features. So let's take a look at this first question. It wants to know what the y-intercept is. Well, here's the y-axis. So where does our line intercept the y-axis? Right there at 16. We look at the answer choices. The water level increased per day. No, that would be slope. When something is per day, rise over run, over and over and over, that's slope. Definitely not F. The maximum the water level was, well, that would be a maximum. The ending point is the maximum in this case. We want the starting point, the y value, the y-intercept. The initial water value, yeah, the starting value. It started at 16 and then it rose higher. H is the answer. This question is asking how many seconds did it take for it to reach the ground? So we're looking at the scenario. Here's our equation. We see the y-intercept is 60. We know that because it's y equals mx plus b, y-intercept and slope. So we have a starting point at 60, the y-intercept, and the slope is showing us it's going down 1.5x. Now, decimals is not what we're used to seeing for a slope, so it's more familiar for us to have rise over run. So let's convert negative 1.5 into a decimal. Well, it should be negative 3 halves. You should be able to do that in your head, but if not, you could have your calculator and type in negative 1.5 math. It's a number we're trying to do, and we want to approximate it to a fraction. Then we hit enter, and it tells us it's negative 3 halves. All right, so that means it's going down 3 over 2. Down 3, 1, 2, 3 over 2. Now, in this case, you see this axis is going by 5s, and this axis is going by 5s. So even though we're counting squares, it's still proportional, and we know slope can be counted in units like this. Down 1, 2, 3 over 2. Down 3 over 2. Down 3 over 2. And we see that the x-intercept is 40. That's when it will reach the ground at time 40. So the answer is 40. The other way you could have done it instead of that way, let's clear the scratch pad by hitting Doc B. Go to the graph, and we can graph this equation, negative 1.5x plus 60. Graph it. Now, many times when students hit that, they think something's gone wrong and it's not showing up. Well, if the y-intercept is 60 and our y-axis window on the calculator is 7.39, of course we're not going to see that line. It's way too high. So we go menu, we want to change the window. We'll zoom out, and we just keep clicking until we can see the line. Okay, so now we see the line, and there we see where it's entering. Now, because of the lines, we can't see. Here's 50, but we don't know exactly where it's crossing. So we'll hit escape to get out of the zooming feature. We go back menu, and we can analyze the graph. We want to know what the 0 is, the x-intercept. It says lower bound, so we click to the left. Then it says upper bound, we click to the right, and it gave us the 0 right there. 40 was the answer. So that's how you can get the calculator to tell you how to do it. All right. This next question asks which line appears to have an x-intercept of 5 and a y-intercept of 3. Well, we look and see for F. Does it have an x-intercept of 5? No. H, does it have an x-intercept of negative 5? No. G, does it have an x-intercept of negative 5? Yes. J, does it have an x-intercept of negative 5? No. We know the answer is already G, but for good measure, let's check the y-intercepts just for practice. Does this have a y-intercept of 3? No. Does this have a y-intercept of 3? No. Does G have a y-intercept of 3? Yes. It's right on both accounts. Does this have a y-intercept of 3? No. So you can tell some of these questions are just very simple as long as you know what an x-intercept is, a y-intercept, and you should also know other vocabulary. For example, another word for x-intercept is 0, of course. We saw that on the calculator. All right, let's try another question. Now here's one that's a little bit more complicated, but still, if you take it piece by piece, it's doable. A lifeguard earns $320 per week for working 40 hours. Now normally when you see the word per week, it's the slope. We're going to be going up and over, but in this case, you can tell the axis as number of hours worked over 40. So it's already assuming that this 40 hours, 320 per week for 40 hours, has already happened. So we're starting, that's the y-intercept in this case, we're starting at 320 because we've already worked that 40 hours. Then it says plus 12 per hour, so that's the slope that we're working with. So if we had our equation, it would be 12x, 12 per hour, plus the 320 that we already earned for working 40 hours. So we check our graphs for the y-intercept first. That could be about 320. That's fine. This is not. There's not giving us the pay for the 320. That's not okay. And G's fine. And then J is bad as well. So now it's between F and G, and we're trying to see which one has a slope of 12. Up 12 over 1. Up 12 over 1. Well, it's kind of hard to tell because it's not going by 12s and we can't see. But what we can do is say, it crosses nicely there, this one crosses nicely here, and see how much should it have gone up if it went over 10 in our x value. And when you work it through, you can see that G is going to end up being the answer. Because if we go over 10, that means we should have gone up 120, because that's 10 times 12 is 120, and 320 up 120 does not just end at 400, so that's not going up enough. This one went over 15 extra, so that'd be plugging in a 15 for our x value, 12 times 15, and that's going to give us the total of 500 that works out. All right, on number 32, we have another example that is pretty straightforward. It wants to know what the y-intercept is. Here's our y-axis. That was a pretty poor line. It crosses at -2. The answer is G. We love those easy ones. The next question, it asks what the 0 is. You have to know that 0 is the x-intercept. It's another word. That's a vocabulary word you just have to memorize. We see that the x-intercept in this case is -6. That's the answer. That's that simple. Now make sure you don't pick either of these distractor answers. They put those dots there just to try and see if kids will put those numbers, but you're smart enough to know what a 0 is and pick it. Next question is another one that's straightforward. What is the y-intercept? Here's our y-axis. Where does the line intersect? And on this one, we don't want to be sloppy when we're looking at it. Here's 6 and here's 5. That line is crossing halfway between 5 and 6. What's halfway between 5 and 6? 5.5. That's what we would have gridded in the bubble sheet. And remember, while we're on it, the bubble sheet, you could type 5.5 on the left, or you could have typed it on the right, but we put it all together and the floating decimal can go in between it. All right, number 23. This one, you have to do a little bit of work. It's not one that's just obvious. It's in standard form. We wanted to get it into y equals mx plus b form. So we're going to have to rearrange it. It's -3x plus 5y equals -15. Well, to get rid of this 3x, we got to go plus 3x plus 3x. 5y is equal to 3x minus 15. And then the last step would be divide by the coefficient on both sides. Y is equal to 3 does not divide by 5 evenly, so we just leave 3/5 x. -15 does not divide by 5, or does divide by 5 evenly, so that's -3. We know our y-intercept, -3. This one does not match, -3. This one does not match. And then we check our slope, up 3 over 5. Up 3 over 5, this one does not match. Up 3 over 5, that one does match. B is the answer. You could have also plugged in zeros for your x and your y to find your x and y intercept. All right, next question is another straightforward one that we like. X-intercept of -5. Here's the x-intercept of -5. No, no, no. Moving to the next one. This is another one where you have to do a little bit of thinking. It's not immediately obvious. It talks about 4 candy bars in each small box, 4 in each small box, and then large box having 24. And we're going to try and figure out which of these graphs match that scenario. So, number of large boxes. If there's one large box, right, it appears if this is the number of small boxes, we're supposed to figure out if what's the equivalency. One large box has how many small boxes? Does one large box have 4 small boxes? Does one small box have 6 large boxes? Well, that wouldn't make any sense. Small box having a lot of large boxes inside of it. So we could immediately rule that one out. One small box having 4 large boxes, that doesn't make any sense. So it's between A and B, and let's see what that really, the equivalent would be. If I have 24 candy bars in one large box, how many of these small boxes with 4 candy bars would be equivalent to that? Well, you should be able to see 24 divided by 4. That would take 6 of these small boxes of 4 each to get the total of 24. So yes, one large box is 6 small boxes. A is the answer, not C. This is another one where you had to know the vocabulary. 0, what is the 0? That's x-intercept. In order to find the x-intercept, you have to plug in a 0 for your y value. The reason why, if we have our graph, we don't want to go left and we don't want to go right. We want to be on the y. Scratch that. We want to stay on, because it's our x-intercept, we want to stay on the x-axis. That means we don't want to go up and we don't want to go down. So our y value can't be positive, can't be negative, it has to be 0. That's why we plug in a 0 for the y value. So let's go ahead and do that. 0 is equal to 8/3 x minus 16. And now we're wondering what the x-intercept is, the x, so we're going to solve for it. To get rid of that 16, we're going to add 16, add 16. 16 is equal to 8/3 x. We need to get rid of that 3. Multiply both sides by 3. These 3's cancel. 3 times 16 is 48 equals, and the only thing left on this side is the 8 times x. Last step, divide by the coefficient. X is equal to 6, which is our answer. In this one, we're trying to compare, and you need some knowledge on transformation of functions to solve this one. It's talking about what's the difference between these. We see the y-intercept is the same in both of them. So we know it's not that it's shifted up or down. So we see what is different about it is the slope. One of them is going up 8/5. The other one's going up 5/8, which is going to, in the end, mean that B is the answer. The graph of P, this top one, is less steep. It only went up 5/8. This one went up 8/5. And then finally, it's asking us for what the x-intercept represents. Well, we know this is the x-intercept, that's 20, but what does that mean in this scenario? Looking at our axes, we see we start with some fuel, and then over time, hours, we're losing fuel down a certain amount and over, down and over, down and over, and then we end up here, 20 hours. What happened in that 20 hours? Well, we ran out of fuel. So the answer that says that is B, the number of hours the truck was driven before running out of fuel. B's the answer. All right, that is TEK A.3C.